Uh, the talk of the title is Event-Driven Time Series Analysis and the comparison of public reactions on COVID-19. This slide shows the outline of my presentation. COVID-19 has emerged as the most aggressive disease impacting most of the countries of the world. Its rapid progression has already affected human lives physically, mentally, and economically. Governments have taken preventive measures like social distancing, lockdown, economic support package, travel ban, etc. However, whether these measures impacted human lives is quite unclear. Therefore, our research questions are, do government responses like lockdown or emergency declaration or economic support package improves human lives? Are publics more worried on health issues than that on the economic issues? To address these research questions, public sentiments will be explored using Twitter platform among 4 countries, Japan, USA, UK, and Australia. First, COVID research in the textual domain reported more negative polarity in corona-related news articles. More negative polarity for less number of topics in the tweets were also found, which were caused due to deaths, increased racism, and economic losses. Also, another study showed dominant fear and surprise emotions in tweets in which economy and politics were the most commonly discussed topics. Current researches on the COVID-19 mostly applied lexicon or machine learning-based approach for sentiment analysis. In this study, a lexicon-based approach called Bashar is applied to address the research questions. Bashar stands for Balanced Aware Dictionary and Sentiment Reasoners, which is a rule-based model which combines lexicon features with 5 rules that embody grammatical and syntactical conventions for emphasizing sentiment intensity and showed effectiveness in the social media data analysis. Bashar is more sensitive to frequently used sentiment, more sensitive to sentiment expressions than widely used lexicon approach LIWC, linguistic inquiry and word count in social media context, which also generalizing the other domains, not only social media platform. This slide shows the block diagram of our approach. So we have a time series data, Twitter data, which is pre-processed and extracted feature from the data, and then applied to the lexicon-based approach to get the score, and which eventually form a sentiment time series for different parameters. In the second part of the talk, a machine learning-based approach were developed, in which the health and economic worry were classified tweet by tweet for the 6-month duration, which eventually predict the time series for the health and economic worries. And finally, event analysis were performed on both cases. This slide informs about our data set. In our study, we used about 28,000 tweets from 4 countries, which were collected using 7 keywords like corona, coronavirus, virus, COVID, COVID-19, etc. And this table shows the statistics on the dataset 1, which shows the number of tweets from each countries. Dataset 2 is a relatively small number of tweets, 494 tweets, in which the health worry and economy worry were expressed in 146 and 349 tweets, respectively. This slide shows the percentage polarity counts in our dataset 1, which shows consistently dominant positive and negative polarity compared to the neutral polarity in each country. And in most of the country, we can see here, US, UK, and Australia, the negative polarity is dominant. Unlike Japan, in which positive polarity is slightly dominant, which is, compared to other countries. This slide shows the time series for the mean polarity for the 4 countries, Japan, USA, UK, and Australia. And here we see the mean polarity has large variation before March. You can see here, here, and also here, indicating the intense public sentiment variations during the earliest stage of COVID-19. The range of the average polarity for USA, is relatively less compared to other countries. You can see the range of this sentiment values. Australia has large variation not only in the initial part before March, also we can see the large variation after April. This slide shows the sentiment time series for the pnRatio, positive negative count ratio, for the 4 countries. Again, we see the similar behavior. Here, average pnRatio has large variation with sharp peaks in Japan, UK, and Australia, with irregular peaks compared to that in USA. You can see the pattern here and here, approximately similar, but the pattern in US is a little bit different. And once again, the range of the pnRatio for the US a bit less compared to the other countries. This slide shows about the event. In this study, we considered 2 events. The starting date of the first declaration of lockdown or emergency in each of the 4 countries, which we called LED event, and the date of the first declaration of economic support package to support the people, business, or industries during COVID-19. We call this event ESP. With these 2 events, we have performed a statistical analysis. This slide shows the result from the statistical error analysis for the 4 countries. And we see that the overall mean polarity is low, indicating approximately equal positive and negative polarities before and after the LED event. So we can see here, this column, this bar shows the before, and this bar shows the after the lockdown event. So what we see here, after the lockdown event, average polarity scores became smaller. That means we can see here the negative polarity is reduced. And here also negative polarity is reduced. Here, these 3 countries shows the similar behavior. So after the lockdown event, negative sentiment slightly improved, unlike Japan, where the positive sentiment is reduced a little bit, which show consistent result with the previous slides. After LED event, average negative polarity scores were improved. We can show here, and this figure shows that the negative polarity is slightly improved in these 3 countries, USA, UK, and Australia. But in Japan, positive polarity is reduced. That means, it shows opposite behavior. This slide shows the statistical error analysis result before and after the LED event, before 15 days and after 15 days, and for the 4 countries. And we see here the average pnRatio have increased for the 3 countries like USA, UK, and Australia, while in Japan, the average pnRatio decreased a little bit. Overall, mean polarity score is lower for the USA, unlike other countries. You can see the range of the value, which is a bit lower compared to the other 3 countries. And to look into a bit details of this behavior, we have performed the Welch t-test on the 4 countries. This slide shows the t-test outcome. And we see here the significant improvement of negative sentiment in UK and Australia after the LED event, while the same significant improvement of the mean polarity and pnRatio after the economic support package in US and UK. However, we did not see any significant difference in Japan for any one of the event. This slide shows the verification result of the tweets before and after the each event, after the LED and ESP event. And we see the USA, UK, and Australia. We see the health worry tweets reduced, economy worry tweets reduced, and also the political partisan bias is reduced in USA. And similar behavior we see in the UK and Australia also we see similar behavior, but health worry slightly increased. And in Japan, we see the health worriness is increased unlike other countries, unlike USA and UK, but economic worry tweets slightly decrease. And also the anti-government sentiment is also increased, unlike other countries. And similar behavior we can see for the economic support package event. So here we have performed we have applied the machine learning approach, logistic regression, to see this behavior, what we observe in the tweets here, economy worry and health worry. We consider these 2 classes as the most important class in the tweets. Of course, we have the sentiment on the government, anti-government sentiment, but we currently focus on the 2 classes, health worry and economy worry. So, and we have performed a classification study using logistic regression. So in this case, the second data set, which is basically used as a training set for the health worry and economy worry, which is directly collected from the social media platform using the specific keywords related to the health and economy worries. And these keywords given here: mask shortage, medical system collapse, bankruptcy, corona recession, damage, and tourism, etc. So, and in the tweets, apart from the health worry and economy worry, we have some other class. So we consider that into other class. So we have performed a 3-class classification problem, supervised classification problems. The training tweets for the 3rd class were used from a open source data set, which we call the US airline review tweets. So, so the data set 2, which is independently collected from the data set 1. And we use the data set, Japanese tweets from data set 1 as a test data set. And we have applied the supervised machine learning approach to classify the tweets for the 6-month duration. And this slide shows the result of classifications. And we see that the blue line is the health worry, and the pink line or orange line is showing the economy worry, and it shows that the Japanese people are more worried on economy compared to the health issues for the whole 6-month duration. This size shows the validation result, and here we see that we have performed the validation. There were about 4,000 tweets, but we manually checked only the 100, and this table shows the classification result over 100 tweets only, and it shows overall 83% accuracy for the health and economy worry classification. And once again, we have verified the before and after the lockdown from the classification results. And we see that once again for Japan, the health worry has increased after the lockdown or economic support package declaration, while the economy worry a little bit decreased. So which is consistent with the statistical error analysis and Welch t-test results. Here we conclude our works. We two approaches, one lexicon and one machine learning based were developed for analyzing public sentiments from the Twitter data. Public reactions were quantified using two sentiment time series, namely the mean polarity and pnRatio time series. Statistical error analysis showed a decrease of absolute mean polarity and an increase of pnRatio after the lockdown and support package event for most of the countries, unlike Japan. Welch t-test showed significant changes of the public sentiment. Therefore, a reduction of mean polarity and an increase of pnRatio in UK and Australia after LED event, unlike Japan and USA, also showed significant changes of the public sentiment in USA and UK after the ESP event, unlike Japan and Australia. Classification with logistic regression model showed higher economy worry compared to the health worry throughout the 6-month period from January to June 2020. Validated tweets showed 50% increase of health worry compared to the case 15 days before the lockdown event, and 2.3% decrease of the economy worry tweets after the LED or ESP event. So in future, we classification studies can be extended with other countries. Here only we have shown the result for the Japan as a case study. And we are also planning to apply fine-grained sentiment analysis with deep learning models in our future work. And also we have a plan to explore relations between corona and mental health problem in our future study. Thank you very much for your kind attention.